So I'm going to use this focuser on the telescope. It's, I think, an Antares focuser. Comes from a guy out in Richmond. Or at least it's the same kind of focuser that goes on an Antares. So dual speed Crayford focuser, kind of low profile. So yeah, that will undoubtedly give the mirrors the best chance of showing what they can do is by putting a good focuser on the telescope and holding the secondary steady. So yep, that's also going to happen on the FreeScope. So this focuser has quite a bit of adjustability, I would say. So that's it, fully contracted. And then you've got probably, I'm going to say, 1.5 inches, but this also extends. So you've got quite a bit of adjustability in your travel, depending on whether you're at far stops or center stops, and then you can got this to clamp down. So it's not a bad focuser. We'll see how it works on the scope. So Stellafani says that the distance between the front of the mirror and the center of the focuser should be 36.525 inches based on a 10-inch diameter mirror on a 2-inch focuser, a 12-inch diameter tube, 0.125 inch wall thickness, and what else was the important parameter there? Oh yeah, the mirror diagonal. The mirror minor diameter was equal to 66.5, and I think that is approximately equal to 2.16 inches. I'll have to check. And the major diameter was equal to 93.5. But we didn't really need that in the Stellafani calculation. So that is what leads us to how far from the front of the mirror. So that's easy. Pull out the mirror cell, do a measurement there, and then translate that measurement down the tube, wrap paper around the tube in order to figure out where a parallel line is at 36.25 inches away from the front of the mirror. Now, we have to figure out roughly where to mount the secondary, because the secondary is going to have to go in here somewhere, and there's going to be some holes to mount it on the tube, and to figure that out. I don't know if you saw any of that crap. So, what are we trying to do? We're trying to figure out where the center line of this secondary mirror is, because the rays of light are going to be coming in here and reflecting up into the eyepiece, which is up here somewhere. Focal plane, blah, blah, blah. So, minor diameter 66.5, since that is the width of this tube, 66.5, there's a little bit of gap around the outside. I'm going to call it 67. I've got room to move on that measurement because I've got some adjustability in here. So opposite angles are equal because this is a 90, 45, 45 triangle. That means the opposite sides are equal as well. 67, 67, so half of 67 is 33 and a half. So that plus 39 plus, okay, let's put it in the middle, so 5 millimeters here, plus 9. So 9, 14, 53. And then, so 76.5, I think. 86.5. What the heck? And 343, 53. Yes. Okay. So 86.5 millimeters ahead of the focuser hole, and so 86.5 divided by 254 is 3.4 inches. 3.4 and 0 inches is how much this distance needs to be. Right here. 3.4 inches. There we go. So that gives us what we need to do for drilling on our tube. And that will come this weekend, I think. Putting on the focuser and putting in the secondary. And then wait for nice weather.